Sometimes we find ourselves requiring the use of the double angle formulas to solve trigonometric equations. In this particular equation, you have sine of t plus sine of 2t equals 0. Solving for t in the intervals 0 to 2 pi not included. And the first thing I notice that stands out to me is that you have a t and a 2t. Those are completely different arguments. And then the second thing that pops into my mind is that we have a formula for sine of 2t that will allow me to write this equation and involve only the angle t. So, looking at the equation sine of t plus twice sine of t times cosine of t equals 0, we see a common factor of sine of t. Oops, jumping ahead of myself there, sorry about that. So a common factor of sine of t. The other factor is now 1 plus 2 cosine of t. The whole thing equals 0, which does mean that sine of t is 0, or 1 plus 2 cosine of t has to be 0. And sine of t is 0 at places like 0, pi, 2 pi, 3 pi, and the negative guys and so forth. We only are told to include ones up to but not including 2 pi. Okay, so we're done with this part of the equation. Here we end up with 2 cosine of t equals negative 1, or cosine of t equals negative 1/2. And now go back and review the section on solving trig equations. Our reference angle from the special triangles would be 60 degrees, as the cosine value of 60 degrees is 1/2. 60 degrees measures as pi over 3 radians. Cosine is negative in quadrants 2 and 3. So the quadrant 2 solution for t will be pi minus the reference angle, and the quadrant 3 solution will be pi plus the reference angle. Now you could simplify those if you wanted, or we could list everything in the box. It did not say we had to list them in order. Okay, and again, if you had wanted to with a common denominator, or if you chose the unit circle approach, you could give these as, simplified angles. Okay, but again, it's the presence of sine of 2t that stands out to me, that basically says you need a double angle formula. Okay,